Section 22.2 Quantum Mechanical Postulate 6 for Atoms. The quantum mechanical postulate 6 states that the total wave function of a many-electron system must be antisymmetric under the exchange of two electrons. Therefore, in a many-electron atom, when we write out the total wave function as the product of the spatial function and the spin function of the electrons, we should realize that either the spatial function or the spin function must be antisymmetric, while the other must be symmetric. And then the product is antisymmetric. Why can we write out the total function as the product of the spatial function and the spin function? We assumed the orbit motion of the electrons is independent of the spin motion of the same electrons. Now let's look at the helium atom. The total wave function of the helium atom in the ground electronic state as 0. So 0 means ground state, S means singlet, with a spin multiplicity of 1. With the ground electron configuration 1s2 is this. Now you see a product of the spatial function here, the spin function here. The spatial function is symmetric. If you swap 1 and 2, electrons 1 and 2, this spatial wave function remains unchanged. This spin function is antisymmetric. If you swap 1 and 2, you change the sign of the spin function. Now let's look at the total wave function of the helium atom in the first excited states. There are singlet excited state S sub 1 and triplet excited state T sub 1. Let's look at this S sub 1, singlet excited state. This one means the first excited state. We also have a product of the spatial function. This tells you the spatial distribution of the two electrons. This is the spin function of the two electrons. So this spatial function is symmetric under the exchange of the two electrons. This is antisymmetric. Now the first excited triplet electronic state. So this means we have a degeneracy of 3 triplet, 3 of them. The wave functions are this 3, and if you look at the spatial wave function, they are exactly the same. Okay, so this 3 spatial wave function give you the same spatial distribution of these 2 electrons. These are the spin functions. In these 3 cases, you'll see the spatial function is antisymmetric. The spin function is symmetric. So if you swap 1, 2, there's no difference. If you swap 1, 2, beta 1 times beta 2 equals beta 2 times beta 1. Same thing. Same here. If you swap 1, 2, you'll get alpha 2 beta 1 plus alpha 1 beta 2. It's the same as alpha 1 beta 2 plus alpha 2 beta 1. Alright, so in summary, the spin function is antisymmetric in the singlet electronic states S0 and S1. The spin function is symmetric in the triplet electronic state T1. On the contrary, the spatial function is symmetric in the singlet electronic states, but is antisymmetric in the triplet electronic state.